Okay, so this next homework will be very similar to the last one. The only thing we're adding, the only thing I'm adding is domain and range. Okay, so this will be kind of more practice with the all the other stuff, and then just adding domain and range on top of that. Okay, and just so you know, for the next one, I'm gonna eliminate this blue stuff, this help. So you're gonna have to do it from memory more. And then the final one will be no help at all. So like this won't be here, like the general form. The blue won't be there, and you have to fill in everything. Okay, so yeah, so real quick, domain and range. I'm gonna do a little thing up here. Okay, so when you do domain, okay, there's always something comma something. The thing on the left, the thing on the left here is how far left the function goes, and the thing on the right is how far right the function goes. Okay, when you do range, okay, same thing, two things separated by a comma, and here there's like two things here. Okay, there's two things. Okay, the thing on the left, when you're doing range, it could be a number, could be in negative infinity. But the thing on the left is how far down the function goes, and this is how far up the function goes. Okay, if there's ever a negative infinity, it's always going to be on the left for domain and range. If there's a positive infinity, it'll always be on the right for domain and range. If there's a number on either one, if there's a number anywhere, sometimes it'll have a bracket, sometimes it'll have a parentheses. Okay, and we'll see kind of as we do problems what type of problems will have parentheses and which ones will have a bracket. Okay, and then, yeah, that's kind of the main thing. All right, so let's start doing problems. Okay, so we'll do this constant function first. Okay, and my advice is to do domain and range last, after you graph. Okay, so y-intercept. You see y-intercept is 0, comma c, and then c is just whatever the number is that you're given. So for this one, it'll be 0, comma negative 5. Okay, slope is always 0. So, okay, and then we graph it. Okay, so we go down to negative 5, y equals negative 5, and that'll be this. Okay, oh, and do you see, the other thing, there's no, on the previous one, I put a guide of what the general shape looks like. So for this one, you'll have to memorize, or remember what the general shape looks like too. Okay, so we graphed it. Okay, so now domain for this one. And we actually have done this. We did this in the first one in class a couple weeks ago, I guess. So this will be a little review also. But okay, so domain. So remember domain, you think how far left and how far right. So you can see this goes left forever. That's what this arrow means. And this goes right forever. So the domain, so left forever is negative infinity. Right forever is positive infinity. Okay, so you can see the negative infinities on the left, positives on the right. And either infinity, whether it's negative or positive, always gets parentheses, never brackets. Okay, this range is different than the others. You can see how far down does this go? How far up does this go? This doesn't go down or up, you know, any amount. All it does is go through -5. So this range is just a single number, -5, and you put it in those squiggly brackets like that. Should be like kind of three thingies, 3 little bumps, I guess. Okay, next one. Okay, so we see the general form, mx plus b. So m is whatever's multiplied by x. So in this case, that's 3. I'll write that, m is 3. Okay, you can see b is whatever's added. So b is 9. Okay, we can fill in all this stuff now. So you can see the x-intercept is -b over m, comma 0. Okay, so -9 over 3. So the x-intercept is -9 over 3. And that's just -3. So -3, comma 0. Okay, just so you know, you could also, to get the x-intercept, you can always set the function equal to 0 and solve for x, and you'll get the x-intercept. And that goes for any function. Okay, y-intercept is 0, comma b, so 0, comma 9. The slope is m. Actually, and just so you know, so the x-intercept for every function, you could set this whole function equal to 0 and solve for x, and that'll be the x-intercept. To get the y-intercept, you can plug in 0 for x and simplify, and that'll be the y-intercept. Okay, so you don't have to necessarily memorize x and y-intercept. You could just solve for it every time. Okay, slope is m, so that's 3 for this one. Okay, so let's plot the 2 points, -3, 0, and 0, 9. And we'll draw a line through it. Okay, domain, how far left? This goes to the left forever, so -infinity. This goes to the right forever, so +infinity. Okay, range, how far down? Forever. How far up? Forever. That's it. Okay, so for linear functions like that, that'll always be the domain and range. All real numbers, you know, -infinity to +infinity. Okay, next one, absolute value. So for this one, h and k, so this is the first h and k one so far in this worksheet. Okay, so h, remember, is whatever's with x, and it's the opposite, so it's x minus 4, h is +4, and then k is whatever's on the outside, it's 3. Okay, so the vertex h comma k, whoops, is 4, comma 3. Okay, we could see after we graph, but this is facing up because the number on the outside is positive. Okay, do 2 additional points, h minus 1 and h plus 1. Since h is 4, h minus 1 is 3, and h plus 1 is 5. All right, we plug those in. Okay, so plug in 3, so we get 2 times absolute value, 3 minus 4, 3. Okay, so 2, and then keep in mind this here. So the absolute value of 3 minus 4, so 3 minus 4 is -1. Actually, I'll write this out. That's 2 times absolute value negative 1 plus 3. And then the absolute value of negative 1 is just 1. So this whole thing is just 1. And then 1 times 2 is 2. This will be 2 plus 3. And that's 5. Okay, so you plug in 3, you get 5. So 3 comma 5 is a point. Okay, next one, we'll plug in 5. So 5 minus 4 plus 3. Okay, 5 minus 4 is 1, so it's absolute value of 1. And then same thing, absolute value of 1 is 1, times 2 is 2. This is 2 plus 3, which is also 5. Okay, so you plug in 5, you get 5, so that's the other point. Okay, so we have three points to plot, 4 comma 3, which is the vertex, 3 comma 5, and 5 comma 5. Okay, and then since this is the vertex down here, 3 comma 4, we go out from there, just something like that. Okay, so domain and range. So domain, we look at how far left does this go. So this goes up and to the left forever. So it goes to the left forever. That's negative infinity. And then it goes up and to the right forever. So it goes right forever, which is positive infinity. Okay, range. So range, first you think about how far down does it go. So it doesn't go down forever. The farthest down it goes is to 3. You can see that's the y coordinate of the vertex. So it goes down to 3. And then the farthest up it goes is forever. So that's infinity. Infinity always gets a parentheses. And then the fact that there's a point here means that the function equals 3 at this point. And so if there's a point there and the function equals that number, then this will have a bracket here. Okay, so you'll see sometimes this will have a bracket, sometimes the numbers will have parentheses. Usually when there's an asymptote, there will be a number with parentheses in either the domain or range, one of the two. Okay, that's good for that. Okay, next one. So for this one, h is negative 6, k is 2. Okay, so the vertex is negative 6 comma 2. Okay, this will be facing down because of this negative here. Okay, to find the two additional points, plug in h minus 1 and h plus 1. H is negative 6, so h minus 1 is negative 7. H plus 1 is negative 5. Okay, and we'll plug those in to get the y coordinates. Okay, so negative, so just plugging it into this function up here. So negative 7 plus 6 squared plus 2. Okay, so this will be negative, and then this inside here, that's the thing that's being squared, is negative 7 plus 6, which is negative 1. Let's still have that plus 2. Okay, so you just got to be careful. You got to do this exponent first. So negative 1 squared is a positive 1, but then you have this negative out out front. That'll make that a negative 1 again. And then plus 2. Whoops. And then negative 1 plus 2 is 1. Okay, so you plug in negative 7, you get 1. So negative 7, 1's a point. Okay, and I'll plug in negative 5 into the function. Okay, same thing, this will be negative, and then here, negative 5 plus 6 is a positive 1. And then this is the same thing. So 1 squared you have to do first. That's 1. And then this negative will make it a negative 1. And then that's 1. Okay, so you plug in negative 5, you get 1. So that's a point. Alright, so let's plot all these points. So the vertex, negative 6, 2. Right there. Negative 7, 1. Negative 7, 1 is a point. And negative 5, 1. Okay. Okay, since this is the vertex here, it'll go out from there. Like this. Let me erase this. This is weird. Alright, and then we don't need this. I'm going to try to make this exactly like, okay. Now, domain and range. Think how far left does this go? This goes down and to the left forever, so it goes to the left forever. How far right does it go? Let me use a different color. This goes to the left forever. And then how far right does it go? Same thing, it goes down and to the right forever. So it goes right forever. Okay, for the range, how far down does it go? Always think down first, so it goes down forever. So that's negative infinity. And then it doesn't go up forever. The farthest up it goes, so negative 10, negative 5, 0, 1, 2 is the highest it goes, to y equals 2. And so the highest it goes is to 2, and it equals 2 because there's a point there, so we put a bracket. Okay, next one. All right, h in this case is 4, the opposite of what's with x. And then k is 0 since there's no k written. So the middle point, this is a cubic function, so this has a middle point. That's 4, 0. Okay, this type we plug in h plus 1 and h minus 1. So h minus 1, if h is 4, that's 3. H plus 1 is 5. So we'll plug those in to that function. So f of 3. Okay, plug in 3, so we get 2 times 3 minus 4 cubed. So 2 times, okay, so 3 minus 4 is negative 1. 2 times negative 1 cubed. So if you raise a negative number to an odd exponent, it'll stay negative. So this will be negative 1. That's negative 2. 2 times negative 1 is negative 2. Okay, so you plug in 3, you get negative 2, so 3, negative 2 is a point. Okay, next one, plug in 5, so 2 times 5 minus 4 cubed. Okay, 5 minus 4 is 1. 1 cubed, this is 1, so 2 times 1, that's positive 2. So plug in 5, we get 2. 5 comma 2 is a point. Okay, so let's plot all this stuff. We got 3 points to plot. 4 comma 0. 3 comma negative 2. And 5 comma positive 2. Okay, and then remember for cubics, the 3 points that we get should all be in a line, but remember it's not a straight line. So this is a curvy little thing. So from the middle point it kind of curves up, goes up really quickly, and then to the left it curves down and goes down really quickly. Okay, the fact that this function goes to the left and right forever and goes down and up forever, you can see the domain for this one and the range will just be negative infinity to positive infinity. Right, down for, so for the domain it goes to the left forever, goes to the right forever. Range it goes down forever, goes up forever. So okay, next one. All right, for this one, h is -1, opposite with the x, and k is 5, -5, same as the outside. Okay, so our endpoint is a square root function. Square root functions have endpoints. Endpoints -1, -5. Okay, 2 additional points for this one. You have to add 1 and add 4 to h. And you can kind of think of it, square root of 1 is 1, square root of 4 is 2. So it's like, or you can think like 1 squared is 1, 2 squared is 4. And that's what you'll add. You know, maybe just to remember. Okay, so h is -1, so h plus 1 is 0, and h plus 4 is 3. So plug those in. So remember, we're plugging it into here, this function. So 3 times, oops, square root 0 plus 1. Okay. So the square root of 0 plus 1, you know, 0 plus 1 is 1. Square root of 1 is just 1. So this is just 1. And then 3 times 1 is 3, minus 5 is -2. Okay, now we'll plug in 3 into the function. 3 times square root of 3 plus 1 minus 5. Okay, 3. Okay, so 3 plus 1 is 4. Square root of 4 is 2. Okay, 3 times 2 is 6. So you have to do this multiplication first. So 3 times 2 is 6, and then 6 minus 5 is 1. Okay, so we plug in 0, we get -2. Plug in 3, we get 1. So our points. Okay, so we'll plot the endpoint first, -1, -5 down here. 0, -2, and 3, 1. Okay, we keep in mind this here is the endpoint, so the function will go start from the endpoint and then go through the other points and then kind of go along that same path. Okay. All right, and then, okay, domain and range. Okay, so think how far left for domain. How far left does this go? So this doesn't go to left forever. The farthest left it goes, as far as x values, is -1. And there's a point there, so it'll be a bracket -1. And then how far right does it go? You can see it goes to the right forever. So that's infinity. Okay, now think about it doesn't go down forever for the range. So the farthest down it goes is to -5. And it equals -5 since there's a point there, so we'll put a bracket. And then it goes up slowly, but it goes up forever. So that's positive infinity. Okay, and you can see these numbers here are really h and k, and that'll always be the case. The number with that is with domain will always be h, and then the numbers that is with range for this function for square root, the number will always be k. Okay, so there's a lot to memorize, but there's also a lot to like kind of understand that'll help you just kind of remember how to do this. Okay. All right. So next thing, rational function. Remember, this is the rational function is the one with the fraction, and this has two asymptotes. All right, so vertical asymptote, or actually h and k. So h is whatever's with x, but the opposite. So it's x minus 1. So h is a positive 1. K is whatever's on the outside, which is 2. Okay, the vertical asymptote is x equals h. So for this one, it'll be x equals 1. The horizontal asymptote, y equals k. So for this one, it'll be y equals 2. Okay, for the two additional points, you do h plus 1 and h minus 1. Okay, so h is positive 1, so h minus 1 is 0. H plus 1 is 2. All right, so we'll plug those in. Okay, we'll plug that into the function up there to the right. 4 over 0 minus 1 is 2. There's not much room, but okay, so 0 minus 1 is -1. Okay, 4 divided by -1 is just -4. And that's -2. Okay, and then we'll plug in 2. So this will be 4 all over 2 minus 1 plus 2. 4 all over, so in the bottom, 2 minus 1 is just 1. 4 over 1 is a positive 4 plus 2, and that's 6. Okay, so those are our points. So we plug in 0, get -2. Plug in 2, we get 6. Okay, so now we'll start doing asymptotes, dashed lines. So first asymptote is x equals 1. So just go on the x-axis maybe, go to where x is 1, and then draw a vertical line that's dashed. There should be some dashed line. Okay, and then the horizontal asymptote is y equals 2. So go y, this is y equals 0, y equals 1, y equals 2, and then draw a horizontal line that's dashed. All right, now we'll plot points. So 0, -2 is a point. And then 2, 6 is a point. Okay, and then we have to know the general shape. So the general shape, you know, from each point, it'll like go up towards one asymptote and then down towards the other. Same thing from this point, it'll go in the direction of one of the two asymptotes, and then this one will have to go up to go start following the other asymptote. Alright, that's it. Okay, next one is an exponential function. Oh, I didn't change that. Oh, I gotta change that. Okay, I'll do that later. Okay, so exponential function for this one. H is 0 since there's nothing added to x. It's just x by itself. And then k is -10. Whatever's added or subtracted on the outside. Okay, so the horizontal asymptote, y equals k. So for this, it's y equals -10. Okay, the turning point is h comma a plus k. So h is 0, so this will be 0. And just so you know, you could also just plug in 0 for x and then get the y coordinate here. You don't have to memorize a plus k if you don't want. Just plug in 0 and that'll be the y coordinate. And that's true for any point. You know, anytime you have the x coordinate of a point, you just plug it into the function and you always get the y coordinate. Okay, but I'll do it the memorizing way just to make it quicker. So in this case, a, you can see in the general thing is whatever's multiplied out front, which is 2 for this function. And so a plus k is 2 plus -10, which is -8. And that's our turning point. Okay, so for these, usually do h plus 1 and h plus 2. Since h is 0, h plus 1 is 1, h plus 2 is 2. We'll plug those in. Oops. Okay, there's not much room here. Let me do this. Okay, so plugging in 1 into that function up there to the right, be 2 times 3 to the 1 minus 10. Okay, so always do the exponent first. So that's just 2 times 3 minus 10. 3 to the 1 is just 3. Okay, 2 times 3 is next. You have to do multiplication next. So that's 6 minus 10. That's -4. Okay, for f of 2, plug in 2. 2 times 3 to the 2 minus 10. Okay, 3 to the 2, 3 squared is 9. Okay, 2 times 9 is 18. That's 8. Alright, so we plugged in 1, we got -4. Plugged in 2, we got 8. Alright, so let's do, this one has a horizontal asymptote, y equals -10. So at -10, draw that, and then plot we got 3 points to plot, 0, -8, 1, -4, and 2, 8. Alright, now this was a turning point here, so it goes up really quickly towards the other points, through the other points, and then goes down really quickly towards the asymptote. Or down really slowly. All right, so domain and range. So domain, how far left? We can see this goes to the left forever. So that's negative infinity. Okay, how far right? It goes up really quickly, but it's still going to the right slowly forever. So this goes to the right forever. So that's positive infinity. Okay, for range, we see it doesn't go down forever. So the range is not going to start out with negative infinity. So the farthest down it goes is to negative 10, but it doesn't quite equal negative 10 ever, since you know these lines will approach the asymptote but never touch it. So this never touches negative 10. So the lowest it goes is negative 10, but it doesn't touch it, so we'll put a parenthesis. Okay, so that's how far down it goes. How far up? You can see definitely forever. So that's infinity. Okay, last one, log. And again, I kind of forgot about that, messed this up. Let me see if I can fix this a little bit. No. Okay, so you can see, can you, this turning point, that should be h plus 1. Comma k. All right, so for this one, h negative 2, k negative 4, and b, in this case, the base of the log is 2. We'll need that for the additional points. Okay, so vertical asymptote, they say is, it says x equals h, x equals negative 2. Okay, the turning point, h plus 1, so that's negative 1, comma k, which is negative 4. Okay, to get the two additional points, you do h plus b, which for this one, you do h plus b, negative 2 plus 2, that's 0. And then h plus b squared, so b squared is 4, so negative 2 plus 4 is positive 2. Okay, so these are the numbers that we'll plug in to the function. To get the y coordinates, so this will be 3 times log base 2 of, okay, plug in 0, 0 plus 2, okay, 3. Okay, you can see this 0, so 0 plus 2 is 2. So this inside here is 2. So, and then log base 2 of 2 is just 1. So this is 3 times 1. And then we can see 3 times 1 is 3, and 3 minus 4 is negative 1. Okay, so now we'll plug in 2. Okay, so that 3 will rewrite, and then log base 2 of 4, right? 2 plus 2 is 4. So log base 2 of 4, this whole thing, is 2. Right, and just a reminder, you think 2 to the what power equals 4, and that's how we got that 2 here. It's 2 to the 2, 2 squared equals 4. Okay, you got to do multiplication next. So 6, and then minus 4 is 2. Okay, so you plug in 0, you get negative 1. Plug in 2, you get 2. Alright, so let's do the asymptote first. This has a vertical asymptote at negative 2. Okay. And then the turning point, -1, -4. Additional points, 0, -1, and 2, 2. Okay, and then, so from the turning point, here's the turning point here. So from there, goes up towards the other points and then kind of curves, levels off mostly. In the other direction, it'll follow the asymptote, go left really slowly, but follow the asymptote. Okay, domain. So you can see for the domain, it doesn't go to the left forever. It goes left as far as the asymptote, which is -2. But since there's an asymptote there, it never equals -2, so we'll put a parenthesis. And then this goes to the right forever, so that's infinity. Okay, range, how far down does it go? Down forever. How far up does it go? It goes up slowly, but it still goes up forever. And that's it. Okay, so, you know, exactly the same as the last one, just adding domain and range and taking off the general shape. So I got rid of that. So this will be a little practice, you know, a lot of practice from the last one, just this extra domain and range. Oh, did I not do domain and range for rational? Oh, that's weird. Oh, sorry, let me go back and do this then. Oh, this is the weirdest one too. I don't know why I forgot. All right. So, yeah, okay, so domain. So yeah, this one's different. So this goes to the left forever and goes to the right forever, but it never goes through x equals 1. Right, so here this piece never goes through 1, and this piece never goes through 1. So we have to kind of eliminate 1 from the domain. You know, the domain is all the x values that the function passes through. And so this goes to the left forever, but it doesn't pass through 1. And so that's why we'll put a parenthesis. And then it picks back up at 1, and then it goes to the right forever. Okay, so you'll have these two pieces for the domain, and whenever you have more than one piece for domain and range, you kind of connect them with a U. It's called union. Just kind of unions them together, puts them together. Okay, and then range is similar. You can see this goes down forever and up forever, but it doesn't go through +2. Right, this piece doesn't quite reach +2, and this piece doesn't quite reach +2. So this function never goes through +2 in the range. And so this will go down forever, but it'll go as high as 2. It won't equal 2. And then pick back up at the other piece, 2 won't equal 2, and then it'll go up forever. Okay, two different pieces means you'll have to union them. Okay, and can you see this number 1 is h, and this number 2 here is k, and that'll always be the case. So you could memorize that. If you have a good memory, you could just kind of memorize that. If not, you might have to look at the graph each time and figure it out. All right, so I think that's it. Let me look back. Yeah, that's everything. Okay. And if you have any questions, yeah, just ask.